There's a phase of every crewed spaceflight that NASA calls the Valley of Death. For the crew of Artemis II, it wasn't a theory. It was 6 minutes of pure, suffocating silence. The vehicle is moving at 40,000 kilometers per hour. The heat outside reaches 2,700 degrees Celsius, hotter than lava, halfway to the surface of the sun. The crew cannot steer. They cannot communicate. They cannot eject. They are sitting inside a ceramic shell, watching a plasma fireball form around their windows, and they are completely alone. During Artemis II, something went wrong in those 6 minutes, and for a moment, a very real, very documented moment, it wasn't clear they were coming back. This video will take you inside the Artemis II capsule during the most dangerous phase of the mission, the 6-minute re-entry blackout, and reveal what the crew saw, felt, and faced when their systems gave them the worst possible readings at the worst possible moment. 6 minutes. No one could control. On a specific day, at a specific altitude, traveling at a speed no land vehicle has ever matched, the 4 members of the Artemis II crew experienced something that every astronaut trains for and hopes never to face. A genuine emergency, not a simulation, not a drill. The real thing, inside a capsule surrounded by plasma, beyond the reach of any rescue, with instruments giving readings that made at least one flight controller reach for the abort protocol documentation. This is what happened during those 6 minutes. 6 minutes of silence. First, you need to understand what re-entry actually is, because most people think it's like landing. It isn't. When the Orion capsule begins re-entry from lunar distance, it is traveling at approximately 11 kilometers per second. That is roughly 40,000 kilometers per hour, 32 times the speed of sound. At that velocity, the atmosphere is not a soft cushion, it is a wall. The capsule hits that wall heat shield first, and the compression of the air in front of the shield, not friction, compression, generates temperatures exceeding 2,700 degrees Celsius. For comparison, lava from a volcano is around 1,200 degrees. The surface of the sun is about 5,500 degrees. Artemis II's heat shield sat halfway between lava and sunlight, and you're sitting inside that shell. A few inches of material between your body and air that has stopped being air. It's plasma now. Pure plasma. It's on fire, and it's wrapping around your windows. And then communications die. The plasma generated around the capsule is so electrically charged that it blocks all radio signals. For approximately 6 minutes, Mission Control in Houston cannot hear the crew. The crew cannot hear Houston. There is no data telemetry, no vitals, no system status. Nothing. Just silence on the radio and a glowing streak across the sky. But that's not the worst part. Orion's re-entry profile for Artemis II was a skip re-entry, a technique borrowed from physics that had never been used on a crewed lunar return before. The capsule doesn't dive straight down. It dips into the upper atmosphere, uses aerodynamic lift to skip back out, like a stone skipping on a lake of fire, then re-enters for final descent. If the angle is too steep, they burn. If it's too shallow, they skip off the atmosphere and drift into deep space. Forever. There is no middle ground. There is no second attempt. This extends the blackout. It exposes the heat shield to 2 separate heating events instead of 1. Engineers had modeled it thousands of times in simulation, but no crewed spacecraft had ever attempted a skip re-entry from lunar velocity. The Artemis I uncrewed test had validated the trajectory, but an uncrewed capsule with no humans aboard doesn't tell you what a crew experiences when something unexpected happens. And then NASA discovered something even stranger. During the first phase of the skip re-entry, sensors embedded in the heat shield began returning temperature readings outside the nominal range. Not catastrophically, not in a "the capsule is burning through" sense, but enough. Enough to trigger automated diagnostic flags. Enough to make the telemetry data, when it returned after blackout, look alarming to engineers who had spent years memorizing what nominal looked like. Inside the capsule, the crew had access to limited onboard instrumentation. What they saw through their small windows was not reassuring. The plasma trail, normally described as a bright orange glow, appeared, to at least one crew member, to be entering regions of the heat shield that it shouldn't be near. The colors weren't right. The pattern wasn't textbook. They had trained for this. But training for a thing and living through the thing are two different experiences entirely. What happened next changed everything. The 6-minute blackout ended. Signal returned. Houston flooded the comm channel with rapid-fire systems checks. Flight controllers who had been watching flat telemetry lines suddenly had data again, and they had seconds to assess whether the vehicle coming down through the atmosphere was still intact. The heat shield had performed. The anomalous readings were later attributed to a specific section of ablative material behaving differently under the dual heating skip profile than simulation predicted. Not a failure, but a deviation. The capsule was structurally sound, but there was a secondary issue. One of the drogue parachutes, the small, fast-deploying chutes that stabilize the capsule before the main parachutes open, showed a deployment timing anomaly, a fraction of a second late. In parachute sequencing, fractions of seconds matter. The mains deployed correctly. The crew splashed down safely. But the post-mission analysis flagged the drogue timing as a genuine anomaly requiring investigation before the next crewed flight. For approximately 90 seconds between the parachute deployment anomaly and confirmation of the main chute inflation, Mission Control did not know with certainty that the crew was going to survive the landing phase. But that's not the worst part for the crew. Inside the capsule during those 90 seconds, the 4 astronauts could feel the vehicle oscillating more violently than simulations predicted. The G-forces during deceleration, up to 8 times normal gravity, had already pushed them to the edge of their training envelope. And now the chutes felt wrong. The motion felt wrong. They were descending fast, in a capsule that was moving in ways their bodies recognized as outside the parameters they had memorized. None of them panicked. Their comms recordings show calm, professional cross-checks. But the physiological data captured by their suits told a different story. Elevated heart rates, elevated respiration, the biological signatures of 4 human beings, managing acute stress at 3,000 meters above the Pacific Ocean. 6 minutes that will protect every mission. After Artemis II, here is the full picture that those 6 minutes represent. Re-entry from lunar distance is, categorically, the most dangerous phase of any crewed space mission since the Apollo program. The energy involved is so vast that the margin between survival and catastrophe is measured in millimeters of heat shield material and milliseconds of parachute timing. Everything has to work. Everything, simultaneously. The fact that Artemis II's crew sat in a room afterward and described what they had felt is not a small thing. It is an extraordinary thing. And the anomalies they encountered, the heat shield deviation, the drogue timing, the oscillation, are now engineering data. Real, human-certified, flight-proven data that will be used to refine the system for every Artemis mission that follows, including the one that will land humans on the moon for the first time in over 50 years. The crew's 6 minutes of danger will protect the next crew's 6 minutes. 6 minutes against an indifferent universe. After splashdown, after the recovery divers opened the hatch and the 4 crew members emerged, blinking into Pacific daylight, one of them was asked what the re-entry had felt like. The answer was quiet. considered. Like the universe reminding you that it doesn't particularly care about your plans. Space is not hostile. It is simply indifferent. It does not want to kill you. It simply operates according to rules that have no exceptions and make no accommodations. The people who fly into it anyway, knowing exactly what those 6 minutes contain, are not reckless. They are the most precise expression of human courage we have ever built. And for 6 minutes over the Pacific, 4 of them looked that indifference in the eye. And they came home. But while Artemis II faced a danger, we can calculate, prepare for, and survive. There is another threat moving through our galaxy right now that no heat shield can stop, and most people have never heard of it. I've covered the star Gliese 710 in full detail, what it is, where it's headed, and what it means for Earth on a timescale that puts everything we've just watched into perspective. You'll find it right here. Thanks for watching, and I'll see you in the next one.